Oh, what? Hey, Byrne! Byrne! Dude, it's me, Wade. Where have you been? You haven't been returning my calls, man. I've been really worried.
Oh, hello, Wade. Namaste.
Namaste to you too. Where have you been? I haven't heard from you in weeks.
I've been at the Chopra Center for Holistic Medicine and Quantum Healing. It's quite enlightening.
Dude, you look homeless.
Yeah, it was pretty expensive. I am actually homeless right now.
Okay, well, look, why did you go to that camp?
I started because I thought it would be interesting to see their side, and I've learnt a lot. For example, did you know that orderliness is the foundation of quantum fulfillment?
I don't think that's the case. I don't even know what quantum fulfillment is, but okay, if you say so.
Well, did you know that your heart is entangled in self-righteous destiny?
Okay, I think you've gone overboard with this whole quantum and entanglement thing. How about we go see Dr. Ferrie?
Dr. Ferrie, is he like a doctor for cosmic beings or a boat doctor?
Let's get to it. How hard this was to research and try and sound genuinely like I was doing work.
Dr. Chris Ferrie is a research fellow at the University of Technology, Sydney, whose work focuses on quantum mechanics and in particular quantum computers. He's published research papers as well as baby books about the quantum world, and much of his focus these days is on effective communication regarding quantum physics. This is his second appearance on Sci-gasm, so this time it's his own fault he's here, and we can now say he should know better. You know? Welcome back, Chris. Thanks very much for joining us again.
Yeah.
And you should really speak to the cleaner about leaving the back door open so we're able to sneak through. Welcome back. This is your second appearance on the show. Thank you so much for joining us. We really appreciate your time.
Yeah.
And,
I figure you guys need the help, so...
Oh, we need as much help as we can find.
Absolutely. It's that obvious, isn't it?
So, today we asked you to address some ideas floating around the internet, like about quantum mechanics, because on the internet, quantum mechanics is one of those things that I think is really misunderstood, and I think it's even just because there's so much woo out there with things.
It does. It gets hijacked by woo peddlers, doesn't it?
Yeah, it does. It does. And then
that's the only problem with the internet. It's just everything else is fine. It's just quantum physics. That's the problem.
Yeah, it's just quantum physics. That's the only thing we've found wrong with the internet so far. As well, one of the things I found incredible is so many people with quantum mechanics degrees so active on all the forums. I think that's amazing. That's not what it means. It means this. And you're like, oh, this guy doesn't know what he's talking about because I don't know what I'm talking about. That doesn't even make sense and that's wrong. So, yeah.
No wonder they're so unproductive.
do you ever get into arguments with people online?
No. I'd never go.
It doesn't sink that low.
No, it's not. It's just... Well, I don't want to say a waste of my time, but yeah, it's a waste of my time.
Because that's how we spend our spare time, just arguing with people. And Byrne spends hours.
I spend way too much, I've almost been divorced, actually.
He's not even joking.
Have you ever changed anyone's mind?
I've changed a couple people's mind. Well, I would more say I've shifted their opinions than completely changed their mind. I think would be a more accurate.
It's all worth it in the end.
Yeah. Well, look, that's a minority of people. It makes me feel better, though, especially then when I get to call them a fuckwit or something. So,
and hashtag it too.
Yeah, that's right. We get some good material out of it.
We do.
Now, I think my first question about quantum physics, especially because, I know bugger all about it coming from a biology background, is now I've started dabbling a little bit and being in communication with you. Do you think it's fair to say that quantum physics is a new field in the applied sciences, even though it's been around in the theoretical world for a while now?
No.
No?
No, I mean, I guess there's a few ways to answer that question, right? So everything is quantum mechanical. Everything's made of fundamental particles. So all technology is based on quantum physics to some extent. So like electricity is just flowing electrons. So electrons are fundamental particles. So that's quantum mechanical. But did it require knowledge of quantum mechanics to develop it? No. However, I think most of today's technology actually required understanding quantum physics. So some things are obvious, like atomic clock has the word atom right in it. And if you think of GPS, it requires precise timing to work. So it required atomic clocks, which, required knowledge of physics. And then there are things like the laser and MRI. And then, of course, the transistor. We wouldn't understand semiconductors without quantum physics. So pretty much all of our technology today is based on an understanding of quantum physics. But I guess this understanding is different than what you hear about now. So you might call all of that technology like quantum technology 1.0, where it was based on lots of quantum systems all sort of interacting together. Now, since the last 10 years, we've been able to address individual quantum systems and make them do what we want. And we can observe new properties. Well, I mean, they were always there, but we haven't been able to put them to good use until recently.
Wow, that's pretty cool. So much of our world I had no idea was so dependent on quantum.
Yeah, it's all quantum.
It's all quantum, bitches. So even the human brain is kind of involved in quantum mechanics, obviously uses quantum mechanics and things like that. Is there anyone kind of in the field looking at that kind of system and looking at how quantum mechanics plays in the brain?
So there's a legitimate field, it's called quantum biology.
It's got biology, it's not a legitimate field.
Boo! And so these people are looking at, I guess you could say it's material physics, where the material is biological materials.
So material physics, see? Yeah.
So they want to study finer and finer grained understandings of chemical reactions, right? So how you write down some chemical reaction, you have reactants and then product. But the arrow, what's happening with that arrow, right? So you zoom in and you zoom in and you zoom in, and at some point, some quantum mechanical effect is going on when molecules are interacting. It's just a matter of trying to figure out what that is, testable hypotheses about what that is, and then devising experiments to maybe exploit that in some way, make things more efficient, or maybe nature has figured out the most efficient way to do this already. So another area is quantum consciousness, I guess you could say, or the quantum mind, which is a little bit fuzzier.
You're not getting old Deepak Chopra on us, eh?
So some well-known researchers have said things about this, though it's usually well after their retirement, so I don't know what that says about them or the field, but there's I guess it's a bit strange, right? So I don't really know what the story is there, but if you go to the other end of the spectrum, like the Deepak Chopra and the unscrupulous people, the logic is somehow consciousness is mysterious, quantum is mysterious, therefore they're somehow connected. But from fundamental logic, that's not a valid deduction, right? It's like saying, all dogs have 4 legs. These chairs have 4 legs. Therefore, these are all dogs. Right? It's just a logical fallacy. Simple as that.
What if you're sitting on a stool?
Mine would just be blind.
Just one leg, yeah.
Well, stool. It's one of those round stools that you spin around. So where I'm sitting is great now. I'm sitting right above a air conditioning vent, and I'm getting this really cool breeze.
Yeah, I just thought this room was smelling funny. So you went to Deepak Chopra, so you're saying we probably can't cure cancer with thought alone? Is that what you're saying?
Alone? It's interesting. You could say that, when disease is cured by thought, right? It's the thoughts and intentional actions of collections of scientists, right? Without thought...
Oh, that is deep.
Without thought, then we wouldn't have... we haven't cured cancer, but supposing we do, it will take, obviously, thoughts to do it. Just not the thoughts of an individual. The thoughts of an individual are useless.
Oh, you mean my thoughts and prayers tweets aren't actually doing anything? Shit.
Yeah, but might have to do some more.
Did you forget the hashtag?
That's what it is. Not hashtagging it. So, with quantum healing and stuff like that.
Yeah, can you explain that?
No, I'm hoping you can because you're a quantum physicist. So can we kind of pinpoint like things like cancer? Can we kind of say cancer is caused by quantum mechanics?
Well, I mean, I suppose you could say it's caused by physics. I mean, everything.
You're going to, there it is.
Physics.
Everything's caused by physics,
right?
Typical physicist. Yeah.
Well, I mean, the universe on a whole is pretty inhospitable to life, right?
It's like natus. Yeah.
So you could say, the cause of everything that we don't like is physics. But I guess scientists, I suppose you could think of as like jiu-jitsu masters, right? We're trying to use the forces of nature against itself, right? So it's both a blessing and a curse, I suppose.
Okay,
That's awesome.
like
I'm totally claiming scientists as jiu-jitsu masters of the mind. All right, so quantum is more about the subatomic particles and how they're interacting.
False.
Okay. False? Okay, I'm getting corrected so often in this episode. I'm just going to Wade, take it away. So what is quantum then if it's not about the subatomic particles?
So I think the key area where quantum mechanics is useful is when things are well isolated from their environment. So if you imagine like a subatomic particle, it's mostly surrounded by nothing, right? These things are so small that's why quantum mechanics works well to explain those things. But if you were able to build a really large device that was well isolated from its environment, then it would behave in a way described by quantum mechanics.
Oh, that's cool.
That is amazing.
This is what a quantum computer would be.
Yeah. Wow. That's so awesome. And like, are there any kind of examples of quantum mechanics where, like, because obviously we hear a lot of stuff about how quantum mechanics deals with the really small, and then you've got general relativity dealing with the really big. Are there any examples where the two have been married at all?
So one area where we think that we could actually test these ideas of the interaction between gravity and quantum mechanics is in black holes, or at the event horizon of a black hole. So people study theoretical models at the moment of what would happen if some pair of entangled particles were near a black hole and one fell into the black hole and one didn't, and these sorts of things. Of course, like there's other theories of quantum gravity, like string theory, for example, which we at the moment think are infeasible to test.
Yeah. Do you think that's... I reckon they should call it string hypothesis, but it doesn't have the same ring.
Well, yeah, I don't know. Hypotheses are usually things that you can test, right?
Yeah, I guess. But theory kind of... it's always misused, I found. Like, it's just a theory.
Yeah.
By the layman. I think...
String theorem, yeah.
But I guess as well it's a mathematical theory as well. So technically within that it still holds up.
I mean, everything's wrong to some extent.
Yeah.
I've heard that.
I like how you go, everything's wrong. We're like,
I heard someone explain that models, when you think about it, models are just representing the real world. They are just the least wrong. The best model is just the least wrong representation.
That's a very negative way. I'm surrounded by very negative people.
I think it's accurate. I mean,
Yes,
it was actually a statistician. His name was George Box. He said, all models are wrong, some are useful. And I would say the same thing, like, generally about pretty much everything. Everything's wrong. Some things are useful to think about.
That's weird.
Yeah. We wanted to get into some of the common misconceptions around quantum physics. So we often hear something like subatomic particles, like electrons, can be in multiple places at once. Is that because that's really hard to grasp? How can something be in more than one place at the same time?
It can't. So that's wrong.
Okay.
Excellent.
Next question.
Well, this is almost by definition. Like, if you think of, a particle, if you're imagining like something like a tiny little billiard ball or something, part of the definition of that is like its location, right? So to ask the question, is it in two places at once, just doesn't make sense. It's like saying, can I make a square circle? You can say those words, but they don't have any meaning.
Well, What's the sound of purple?
Yeah, exactly. Yeah. So, I mean, it's
Byrne's contribution to this conversation is, what's the sound of purple?
Answer me that.
in quantum mechanics. Yeah, that's actually not a bad question. Because purple's a frequency, right? And sound is a frequency, so presumably...
You could totally make a sound out of purple. Wonder what favourite sound colour it is. No, I'm out. Wade.
It'd probably sound like this. Fuck you, Byrne. Sounds like purple. All right, so some other misconceptions as well. Schrodinger's cat. We hear that Schrodinger's cat, the cat is both dead and alive in a box until you open the box. How does that relate to quantum mechanics?
So the paradox goes, you put a cat in a box. I mean, these were like Germans in the early 1900s, so it's not weird for them apparently. So you put a cat in the box. You put a vial of poison in the box and a hammer that breaks the vial of poison, and it's so sensitive that one decayed atom will make the hammer fall, break the poison, and kill a cat. So you have to describe the decay of the atom quantum mechanically, and since the whole system's isolated, you have to describe the hammer quantum mechanically, and the vial of poison quantum mechanically, and then the cat quantum mechanically. So the whole thing is in this superposition of the atom being decayed or not decayed, and hence the cat being killed by the poison or not being killed by the poison. So there's like a really practical way out of this paradox, which is this whole system has to be isolated. There can't be any environment, right? And so if you like put a cat in a vacuum chamber, pretty sure it's going to be dead.
Very soon, yeah.
Right.
That's really good. I like that.
But if you made like a really big collection of atoms, they would be described quantum mechanically. But then again, this sort of metaphor of things being classical objects, it just doesn't. It breaks down at that point. It's not useful. Again, it's like these models things, right? You can think about it that way, but it's not going to be useful for anything.
Okay. And what about quantum entanglement? So we hear that if two subatomic particles are influenced by, say, the polarity or spin, I should say. So the spin, then if they're paired up, one will spin up, the other one will spin down. You separate them, say the distance of the galaxy or something like that, and then you change the spin on one. Does that change the spin of the other instantaneously? No. Okay.
So there's a good classical analogy, which is just things that are correlated, right? So, we take Byrne's shoes. You don't know what color shoes he's wearing. Maybe he's wearing his pink shoes. Maybe he's wearing his black shoes. And you take one of the shoes to the other side of the galaxy, and you look at it, and you see that it's black. You know instantaneously that the other shoe is also black. Right?
Okay.
So it's not... nothing is traveling instantaneously. It's just things are correlated. You know that two things have been correlated, then they're separated, and when you see one of them, you update your information about the other one.
That's the best example I've heard of quantum entanglement.
Yeah, that is excellent, actually.
That is...
Because one of the other things that comes
I'm
out is
really
quantum
glad.
computers being able to assess every possible outcome at once. And the sort of reliability or how we can send information faster than the speed of light based on this entanglement. I think that's just really cleared it up for me, to be honest. I've never understood that. That's the best explanation I've ever heard with my simple biologist brain.
I like how he's like, it's kind of like counting toes. You're like, and Byrne has 2 feet, right? And if we take one of the shoes, meaning he's got one shoe left.
That's right. What shoes am I wearing?
Well, if you ever watched people in the lab, it's not far from that.
I noticed you're not wearing any shoes today, Doctor. So with that idea, you've done a lot of work with quantum computers.
I've got more of a question. Why are your toenails painted? If you're a podcast, we can say, are his toenails painted? I don't know. You'll have to observe it like Schrodinger's cat to find out. He's got the ways function.
If there are pictures of my toenails on the internet, I'm out.
You're not painted. They're clearly not painted.
I'm going
Wade.
off the grid.
I have to get a photo after whole body and verify. Now, you've done a lot of work with quantum computers and things, and one of the things we hear that quantum computers are able to assess every possible outcome at once, whereas your sort of regular computers can only do a 0 or a 0, whereas quantum computers can do 0 and 0. Is that true? Can quantum computers compute everything at once?
No. I mean, if they could, then they would solve every problem instantaneously, and we know that they can't do that.
That's a bit of a waste then.
Why even bother?
Yeah. Well, thanks very much. We can hear the police and the sirens in the background, so we better get going.
Yeah, so there are a few special classes of problems that we suspect that quantum computers will offer some sort of speed up to. And they're not checking all solutions at once. They just sort of exploit the same structure, mathematical structure, that is behind quantum mechanics.
And so Richard Feynman, well, from what I've heard, Richard Feynman is doing his calculations.
Correct.
He, is that correct?
He's a crank.
Oh, crank. He kind of proposed the idea that, say electron goes through the double slit experiment, it takes every path. How do you represent that mathematically? To the layman sitting there taking every single path, you'd have to do every single calculation. How do you get around that? I quite don't understand that.
Calculus? That's actually not far from the truth.
Yeah, okay.
I mean, it's, again, saying it takes every path is a metaphor. It's not, there isn't a little ball that has several paths in front of it and it takes all of them at once. Thinking about it that way is convenient for some calculations, but it will lead you astray for others, including, your ability to assess people's claims on the internet.
And so the double slit experiment, so in regards to that, from what I hear, physicists hate that. What's the deal with that? So what is the double slit experiment? Why does it confuse people so much?
Yeah, so this is where if you had a screen with 2 holes in it and you threw baseballs at it, you would expect that they would land behind the screen in two different places and nowhere in between. But if you fired electrons or photons, the particles of light, at the holes, you see an interference pattern, and they would actually appear most often between where the 2 holes are. But this is not so surprising if you consider this phenomenon not as a particle but as a wave. Right? So the same thing would be true, and you do this in your grade 12 physics class, right? You create wave patterns in water, and you put 2 of them, and then you see them interfere, right? And you see this sort of funny-looking pattern, not just concentric circles. And that exact same pattern is what happens after you fire electrons at 2 slits. So people say this demonstrates this wave-particle duality, they call it. So sometimes it behaves as a wave, and sometimes it behaves as a particle. But I think, and physicists argue about, well, which is it? And some people say, well, it's not. You weren't offered a choice. It's it's something different, and this is the best name that we have for it.
Yeah. Okay. Cool. So it's
So it's really that we lack the vocabulary to describe the physics rather than.
Yeah. Exactly.
And they're called a warticle.
Yeah. Someone actually has called it a wavicle. So
that sounds better too. Wavicle sounds better. Oh God.
Now, because I've already made myself sound like an idiot, I'm going to ask the next question anyway. Could
7
I use
seasons worth?
Yeah, that's right. Could I use tachyons to become the Flash? And if so, where do I get tachyons?
My website. Tachyons don't exist.
Tachyons don't exist?
No.
Oh, that shattered me. I spent a lot of time watching The Flash trying to work out how to get faster than the speed of light. You saying the TV was lying to me?
Yeah, even more so than the internet.
Why am I wearing this shirt then?
Yeah, Wade wore his Flash shirt today. I should have been wearing that.
Yeah.
Oh, that's disappointing. So it's not possibly at faster than speed of light. Einstein has speed of light as a constant.
Speed of light is constant, yeah.
Okay, so we've got
it's the speed
particles
limit.
that get pretty close to the speed of light, right? They're really low mass particles.
Yeah.
How do they interfere with a lot of those subatomic particles? Because there's this interaction going on in there at the quantum level. What is going on there with particles and waves that allows us energy to interfere with matter in this way and us to measure it?
You'd have to ask a higher energy physicist. So I mean, there's a whole area of physics that deals with what happens inside these particle accelerators. Things get smashed together. Lots of things come out of these explosions, and then they just start naming them.
Spoken like a biologist.
Yeah, it's like the closest thing in physics to biology. You just like categorize stuff and give it names.
Yeah.
I like to think we do a bit more than that, but
Nah.
Explain.
no, you got an infection recently.
Yeah. Actually, some of them are turning to physics to actually try to understand what's going on.
What, with infections? You're not talking Deepak
No,
Chopra.
no, biology.
Oh, okay, yeah. Well, I always who was the one that defined life? He got over physics and went into biology.
Schrödinger. Yeah. What is life? Yeah.
I understand that. So I think there's time for you guys to come around eventually.
Interestingly,
Didn't you explain it through physics though?
Yeah, but that's where you have to start is in physics because that's where the simple stuff is, and then you come round to biology.
So,
I've heard. I can't remember who was. There was some argument between a physicist and like a neurobiologist, and the physicist argued, once we understand fundamental physics, your field is going to be irrelevant. I'll just explain, everything that happens in the brain built up from fundamental interactions. But it goes the other way around too. Like if we understood the brain, then we wouldn't need you, right? We could just simulate you physicists, right?
So it's a race now. It's an arms race.
It's an arms race. Yeah.
and photon torpedoes. Can we make a photon torpedo, and can we go down to the lab and try and make one?
What's a photon torpedo?
A photon
Is this
torpedo.
like another?
Fire the photon torpedoes.
Oh,
Star Trek reference.
Yes.
Isn't it just
God.
called a torch?
You mean like
Laser.
a laser? Yeah. Laser weapons? Yeah, no, there was. What was the American program? Star Wars, yeah. I don't think that went anywhere.
Yeah, I know. It didn't go anywhere, did it?
Yeah.
That's shit.
Star Wars, really unsuccessful franchise.
like
There
I
was
don't know
also
what
this
about
idea that you would like shoot a laser at an Earth-destroying asteroid to deflect it off course. It's possible. Like there is
Energy.
there is pressure that a laser would exert on it.
Yeah. It's interesting because my favourite part about the story, the Star Wars one, which was the Reagan administration, wasn't that who came up wanted to develop that, where they could shoot down missiles just in case the Soviet Union was sending missiles away, and the Soviet Union was, you can't do that because then we can't do that too. They had this big thing, this big standoff about it. Yeah, they weren't happy that one of them could shoot the other one's torpedoes down or some shit like that. It was just crazy.
I think the
This
problem
is why
was
we
they
don't do history. This is why we're Sci-gasm.
they couldn't get the sound right. It was just like it didn't sound like anything, but it was supposed to be like. Fuck it, scrap the whole program.
You get a seriously, you get a slinky in a plastic cup. You go.
Oh.
It goes, doesn't it? Have you ever done it? No. Have you ever done it? Yeah, see? Really? Yeah. Oh, by the way, there's a fourth person in the room as well, just in case you're wondering.
The laser sound expert.
The laser sound expert, yeah.
So do you want to... We should write a grant application together.
Let's do it.
Resurrect the Star Wars program.
That's it. Yeah, I think Disney bought it, so I have to probably buy it off them.
Make some photon torpedoes. Oh, now, last misconception. Look, it's not the last misconception about quantum mechanics, but some of the last misconceptions you hear about are the idea... Hang on, I've actually lost the question here.
It's fucking amateurs, right? Am I right?
You changed the order.
Just try to make it more coherent.
Have you deleted it?
No, I haven't deleted it. What was the question?
There's actually a theorem in quantum physics called the no-deleting theorem.
The no deleting theorem.
You can't delete information.
How's that work?
Hang on a minute. So last question.
Oh, he's explaining something. You're such a prick.
No, that's what it is. So there's a theory in quantum called the no deleting theorem. Would you care to elaborate?
Great question. Great question.
So what is the no deleting theorem? It's not my lecturer who used to say, used to get the shits, professor of physics when I was doing it. He used to, like, if you'd write an equation and you white it out, he'd fucking crack the shits. He'd be like, no, you cross it out. That way you can see where you're working with.
It's something like that.
Is it?
Yeah. Not really. But.
So what is it? What is a no deleting theorem?
It's just a statement that you can't take a quantum system and just erase it. So a quantum interaction, any interaction is something that occurs between more than one particle, and the best you could do is like basically swap the state of that system to another system, right? And you put that in the environment, and then you create heat, basically. So I think it was in the 70s, somebody pointed out that actually this is like the fundamental limit to computation, both classically and quantum mechanically, is trying to delete information. This is where all of the energy goes to.
So Byrne's dick pics are still out there in the ether.
Yeah.
They're not out there. Please don't look for them. You'll be wasting a lot of time, and you'll be disappointed if you found them anyway.
But I thought Snapchat just deleted
Just
it.
deleted it. Yeah. many unfortunate teenage girls have thought that too.
Right.
I thought it was going to be deleted. He told me he loves me.
Oh, jeez. This took a lot of turns this episode. I was really enjoying this, yeah.
Right.
Well, I mean, now,
yeah. Maybe we could just teach them some quantum mechanics and
Yeah.
no deleting.
No deleting. Just kids, don't put it out there. Just don't put it out there.
Learning quantum mechanics could prevent sexting. I think that's the takeaway message.
That's there's one thing we're taking from
Probably
this.
not far from the truth.
Right. I'm getting the vibe from you, Chris, that quantum mechanics could potentially solve everything, though. Not that there's any sort of bias in there.
All right. Well, thank you very much for joining us, Chris. We really appreciate your time. You've wasted your time twice with us now, and we really appreciate it. But if you want to see some of his work, he's got a variety of kids' book out. You may see Mark Zuckerberg with one of his books. Also, as well, you can check out his papers for those people who are really, really interested and have an extreme depth of knowledge. I've got an equation behind me on this board right now that just looks like a bunch of gibberish, but it's got some sort of purpose. So we appreciate your time. Thank you very much.
Yeah. Thank you, guys.